start recording. Okie dokie. So, last time we sort of fleshed out our happy little interface, our API, and now it's pretty functional. We've got, multiple options. We've got sliders, and we've got a checkbox. So that's pretty good, and we still actually do things. And we did this all sort of based on the write the usage code first idea. Just basically, it's like, all right, I want an item called start game. That's what I write as my API. And then we sort of add the minimum stuff to it. So we've done very little. We've got this idea here where we've actually got the string twice. So we might think about adjusting how we do that. I think we mentioned that ImGUI does it like that just appends a number after a hash and then does a custom string drawing to make that work. So we could look into that. So what we're going to do today is we are going to take what we have and sort of solidify it a bit, and we're going to work on the garbage collection issue. So in a native code situation, what you probably do is have just like a memory arena, and if you wanted to allocate some string, you'd probably do that just on a bit of memory that gets cleared every frame. It's like, here's a bucket of like 10 megabytes, and we just shove stuff in there, tiny things like strings and stuff, and then we just yank the whole thing at the end of the frame and start again, because it's all stuff that's we're allocating it and then it goes away, or we could stack alloc. Maybe it's a little risky for strings, actually, for security reasons. So have you heard about the problems relating to that?
No, I don't think so.
So basically, what would happen is a lot of old security bugs would be related to allocating buffers on the stack and like getting the size wrong, and that let like some external person, like if you're writing a string to the stack, and you get the size wrong somehow, like you let the user specify the size, for example, by user, I mean someone on the other side of a network connection, for example.
Right.
As well as the string being stored in the stack, like the return address of this function is stored in the stack. So you'd call into this, someone in here taking values from the network would clobber the stack, change the return address, and so when you exit the function, it would pop out to like wherever you wanted to go. Like, for example, a bit of assembly code, not assembly, like machine code that you've embedded into this string that you've sent. So that would return into your exploit string, and then you've owned the process. At which point,
Interesting.
The operating systems had similar problems, and you'd owned the whole OS. So that was sort of, and then in C++ and stuff, they've added sort of all kinds of security string stuff that I didn't really pay that much attention to, but to try and deal with that in a safer way. Anyway, that's sort of roughly the thing that you might do. I think the better thing is typically to try and do it all on a temporary buffer in native code, in like a memory arena. But for us, we're going to have to use StringBuilder. And one of the reasons we want to use StringBuilder is just because it's pretty standard C# code. So let's start just with a bit of a warm-up, and we'll just go through the code that we've written and find all the places where we've already said, this is something we need to fix. And I think it's just in the drawing code. We've got to do fix me garbage collection here, here, and here. So let's just take those to begin with and see how we go.
Okay.
And I'll hand over to you.
Yeah, I'm just thinking probably we put our working buffer. I was gonna put it in the UI system, but I'm gonna try to just do it where it's used for now.
I kind of like UI system being sort of interfacey, but we'll yeah, it could be in either.
Well, yeah, okay. That's funny. I'm like, I'm gonna do this the way I think he wants me to, and then you're like, I like the way you were gonna do it originally. Okay, no problem.
It's not a big deal. It's a little object oriented ish in that if you put it in UI system, suddenly you have to worry about like, who's accessing it? Is UI update accessing it? Is UI system accessing it? Whereas if you put it in here, then it's like, well, we've constrained where this can be accessed. We've simplified the mental model of the code. So this is probably the best one, thinking about it.
Okay, but that's the one I said I was going to do.
Oh, right. Yeah.
Right, because I said I knew I was going to do it the way you would want me to, and not the way I would probably would have. So I'm like, aha, I know where to put this. But anyway.
So
I guess
simplifying, I think. Sorry, I was going to say simplifying code. I think trumps. I don't know.
ish.
ish stuff, and just like genericizing. You know, it's like we could reuse this. Well, we could, but we could simplify code. So.
Yeah. On that note, this is totally minor, but it's like you tend to declare it here. Sometimes I do it here, because it makes everything at the top like sort of like, and then everything is here. But I don't really care. In this case, it's a buffer. It's a temp buffer. So, and you like calling this working, so I'll just call it working.
Yeah. Okay.
All right. So, next thing. Sure. So I'll just Now here's an interesting question. I guess where's the end method? We have an end method, right? Actually, in begin, I think would be a good time maybe to clear it.
Well,
then I don't have to worry about.
So, I let's leave clearing it for now, because I think what we want to do. I mean, we already have some stateful stuff with begin and end for the sprite batch. And we've got some protection around it. But we're going to be, like, if you think about where we're going to use this, like, we'll be filling it up and clearing it, and so basically begin and end, as far as StringBuilder is concerned, multiple times. Like, we'll do it once for each item. So putting a clear in begin and end might be a bit redundant, and just complicates thinking about the state changes. So I think we'd probably leave that out.
Okay, so it's almost like a pool. Like we check it out when we use it, and we free it when we're done.
Yeah, so like a one item pool, I guess. Yeah.
Yeah. Right. Yeah, because we don't actually pool them. Okay. Yeah. Okay. So this should be. Well, I don't know how this is stopping us. I'll ask that question later. So yeah, working append. Here's the thing. Here's another thing. I don't mind just doing it like this. Some people will be like, "Oh, you gotta append the text," but this is redundant and dumb, so I'll just do it like that. Unless you really want to avoid. This is garbage producing, right? This little guy. Because we're making a copy of the string because we have to. So I do have to.
Garbage.
So I will have to do that, but I don't know if that's actually helping at all.
So the compiler does do something a little bit clever for us, and that is, it will replace things like this. Although I'm not sure about this one specifically because there's just two things, but something like this, it will actually replace this with string.format.
Okay.
If you look at the output, and the reason it does that is it saves like here's an append, here's an append, here's an append, here's an append, because string.append, so this, or string concatenation rather than appending, is a garbage producing operation, so it will replace this with I don't think it replaces it with this automatically. I think it does replace it with string.format.
What about string concat? Is that also garbage producing, or is that a special case?
Everything to do with string is garbage producing because string is immutable.
Yeah, that's true.
So
right.
Yeah. So the thing is string dot.
Well, that's why I wonder. Yeah, that's why I wanted to ask. I guess maybe later why we think this is going to help GC, because I mean, here's a copy of a string right here.
Hang on, point. Yeah. Unfortunately,
unless it's going to automatically that's not going to turn that into a reference, right?
Okay, so let me now. Okay, so we've got.
I can't hear you anymore.
Yeah, your internet's a bit iffy, but let me now we've got this. Let me draw out how this works. So let's get ye olde paint program.
It's actually your internet's iffy. You're the one shopping.
It could be either side. It really could. Actually, I just realized when I checked it before we started, I checked the speed and I didn't check the quality. It could be dropping packets like a madman. Okay, so what have we got? We got working. Got append. We got space.
I hear you fine for now.
Append text, which is, string text. Okay, so let's go through what this is. Working is a buffer, basically. This is StringBuilder. StringBuilder. It basically is stored on the heap.
Yeah, and in Java they call it string buffer. They ripped it off.
Yes, and so this is just this array of characters basically. At the end of the day, I think it does some magic internally, but it's basically implemented like that. Anyway, this is stored in the, what do they call it? The there's basically a set of strings that are internal to the program, the intern table or something. And so what happens when we append in this buffer, it will grab this and go, it'll fill in the first character and we'll fill in that, copying it out of this string that's sitting in the intern table for the program, which is a bit of memory, basically heap memory. So copying these characters in is not a garbage producing operation. So you can see at this point, no garbage has been created. The only time garbage would be created is if the table was like that, and then we had to expand it, and so it reallocates its internal buffer. Does that make sense? Hello? Lost audio. Hello? Oh no. Daniel? Yeah, this is much slower than normal. Oh, we're back. Hello.
I don't know what just happened.
I have no idea. I can hear you. Yeah, I just dropped out for a little while.
Yeah, I don't know. I was asking, does the compiler just decide that all string literals get interned when it's at the compile step?
Pretty much. I can't remember straight off the top of my head exactly where and how they're stored. You can actually add stuff to the interning table through some weird method call somewhere.
Okay.
But basically, yeah, they're all just essentially you can treat them as in the same way all of these are like pointers to the heap, like in C++ or something that would have a little star on it and it would be a pointer.
Right.
This is effectively a pointer to a string. So by doing an append, we're just copying out the contents of this buffer, which is that and a space, into this, and then this does the same thing. This is like if this says foo, this points to a thing that says foo, and all it does is
it makes no difference that one's a reference.
Yeah. So basically, what I'm saying is that string literals and strings otherwise are more or less the same once you start manipulating them. They're allocated in slightly different places, but the end effect is the same. And so this append operation, the reason we use StringBuilder is that this produces no garbage. Like we just dump it in there.
Okay. Well, except in the case where like you like append an integer, right?
Okay. Yeah. So if we do append 3, this will sadly expand out to, in fact, I think it doesn't quite expand out because append will actually has a signature set. Append, and we can check this, int whatever. Append actually has a signature, and so inside this method, but if it didn't, I think we'd have to actually do it manually. But this, anyway, the point is that effectively what happens is it becomes append, like it will call append 3.to string, and it's toString that will allocate a string. So it's a bit wasteful. And so one thing we could do is implement, and you've seen my code for this. I have an extension method that will
back in that day.
Appends an integer as a in a garbage-free way because it has its own working buffer. It's very similar to what we're doing here, and it produces the correct results. So let's come back here and continue working. Okay. So this, for example, is quite happily garbage-free, but then obviously we need to pass something to label. Actually, no, we don't. We're
oh yeah.
Oh, okay, yeah.
We do.
Yeah, have to pass something to label here. So
we have to pass. Well, this is. I don't want to do this though, because then we're just back to where we were before, right?
Exactly.
Is that what we're gonna do?
ToString will allocate a string, so we want to skip that.
Okay, so now we're gonna have to overload this guy.
Mm-hmm.
Oh well, now we're in class hierarchy purgatory, because now I have to make maybe I have to change. Well, that's the thing. Now I don't want to. I'll just make an overload for now, because now we don't have our nice API anymore. We have to pass a string buffer everywhere.
Well, this is why this is the right point to be thinking about. It's like, all right, I know that in a sane world, I could just pass pass strings all day.
I have a reference to it. Mm-hmm.
Yeah, I'm just saying. Yeah, in a sane world, we could just do this all with string, but we actually have to do something with StringBuilder at some point. And so let's just duplicate this method. And
well, I'm just wondering. I don't have to pass in the StringBuilder. It's a better functionally way to do it, but we have the reference to it in UI draw.
Yes.
So I'm not really sure if it matters right now whether or not.
I think making this general, because we will, because sort of as a preview of what we're going to be doing, external code, like we're fixing up all the internal code for now, but external code might want to do a label with a string builder because it's trying to build up some string. You can imagine something like play name and then like plus that, and we want to fix that up in some way we can use it.
And drawstring on sprite batch obviously has that overload too, so we want to probably bring it with us. So I might as well just add it to this on here.
While we're doing it, that's pretty reasonable. Whoops.
And then yes, this is a no up for update.
That's awfully convenient for us.
Override. Yeah. Okay. I think. Yeah, that's reasonable. I mean. Yeah, I'm gonna say that's reasonable.
That seems reasonable to me.
Copying code is not a problem. Copying code is not a problem. Okay, just brainwashing.
Well,
I gotta get over it. Okay,
you can imagine if we didn't copy this code. This is fine, particularly because this is like this. If we didn't copy this code, you can imagine we could do something like label, like working dot append text, and then label working, and we could just do it here. But for 2 lines, we're going to copy that code.
Yeah, absolutely. And the last thing, once I've passed the label, okay. Here's a. Would you just clear it when you're about to use it? That seems then clearing it after you're done and before you use it, right? So I think that's probably the right way to do that.
Yes, you need to define how this is done at some point, and either is generally acceptable. The advantage to doing it this way is you don't really have to think about it too hard. You don't have to.
Yeah.
Like you always have to remember to do it, I guess. It's like, I don't care what state it was in, I'll just blow it away. Whereas if you did it the other way, it's like, well, I hope everyone else got it right. It's like, well, I'm writing this code. I know I got it right. So
yeah, that makes perfect sense. Okay, so yeah, I'll just repeat that for everything else. So I'll do slider. I'll do checkbox. I don't have a to-do on it, but I should have. I'll just I guess. Oh, this is actually no. I thought there was one where you could pass in the beginning, but it doesn't really matter. Working append.
When you say pass in the beginning, I think
grab this
are you thinking of a constructor too?
I'm aware of the constructor, but I was wondering if there was a clear and then reset to this, but I guess there isn't, and that doesn't matter really. That's
it's not that much extra code, I think, is the reason that doesn't exist. Okay, and then there's that. And I just deleted the code that I needed.
And got some redundant parentheses. Item, what was this before? Item name and text. So now it's going to be item. Well, the name is probably still text, but the text is now a string buffer, which means we're going to overload this guy too. Item string builder. Wait, hold on a second. Don't want to clear. See now. Okay. Whoa. We've got a buffer here. So in the cases that I have a buffer already, I don't want to clear it. Clearly, I'll just reload this guy. I'll no op this guy. Oh. What does this one do? Is this override? Oh, poo. I'm all spaghettiing it up right now. I'm just gonna say, hold on a sec.
So now we have to think about how we are how we are getting a little bit of an explosion here. It's only going to be four four calls to item, but you can imagine. Well, let's see. We've got string that, and then string builder. We've got that one, and then we've got.
Do we really want
one,
a string builder for the
one.
ID though? I mean, the name is a canonical ID. I don't know if I would actually provide a builder for that.
Just projecting forward to what we're doing. If we scroll up a little bit, we look at this line of code. You can see that.
Oh, you're right.
Yeah.
Yeah.
And then, of course, if we do that, we've got this thing here where we actually have a list of strings. So we're actually having to store these things. So this is a bit of a thorny issue. So what we're going to do is back out that change, because we want to just solve like one problem at a time.
Yeah.
And rather than trying to project forward and think, what are we going to do with item? Let's just say, all right, this is all good except we have a to string, and now we just move this to BC to string here. Because yes, once we do item, we actually have to stop looking at draw.
One thing at a time. That's the art of programming. Okay. Okay. So slider then.
So slider's pretty easy. Let's just bang this out.
Funny. Why would I have done that? That doesn't make sense. Let's do this.
I think, fortunately, the compiler will actually help you out on that one and combine them. And this was a bunch of basically appends as concatenations anyway. So that makes life easy. Okay. So before we get too excited about anything, let's check it still works. For example, I have build errors. Oh.
Whoops.
So we've broken something.
At least you broke it in the same way.
Let's fix it. Let's figure out what we've done.
Is it a call to no this would have. I'm wondering. I'm gonna just check something because for my own.
That's bizarre.
Is it because the call to drawstring is taking a string builder that we're clearing? But I mean, this must immediately put instructions on the batch, right? Like, it doesn't like, is it idempotent in that sense? Like as soon as I do something with the builder, I don't like if I go manipulate the builder after calling drawstring, is that a problem? Or
it shouldn't, from what I remember about how this method works, but we're in FNA, we can check it out. Hopefully there's not a bug in FNA.
I mean, I know you basically you built you wrote Exon, so I'm sure you're quite aware of all this.
It was a little while ago, but yep.
Was that fun? Or not really? I mean, it was fun until Android, I guess, right?
Actually, that's a pretty good way of describing it. Yeah, you can see it right here. It copies out the characters
Right.
straight away.
So yeah, at that point we don't. Yeah, so that's not debug then.
That's an interesting bug.
Well, it's not printing an item, so it might.
I found the bug.
Name comparison.
So if you remember what we replaced,
text. Yeah, text equals text plus x, and then.
So I mean, we could run this through the debugger. That's probably worth doing. So slap a breakpoint on this one. Let's have a look what it does. Locals.
Oh, it's not appending anything if the focus is wrong.
Yeah.
So if it's wrong, we have to append just the text, because otherwise we just throw it away. Doodle doo. Looks like we're back.
All right. Cool. That's a simple mistake. These things happen. All right. So you can simplify that a bit.
Ternary action, or what do you mean?
Just take a look at my screen, because as you can see, we always append.
Oh, of
text,
course, yeah. We have flexibility now.
And I mean, it's a little bit of unnecessary copying. Actually, hang on. Did you have what I think you had? Maybe not. I'm just thinking what you could do is like label and call the two different versions of label and save yourself a copy. That's probably worth doing just for completeness.
Oh.
So you can see what I've done here. I've actually called, this is a version of label that doesn't do a bunch of string builder copying. This is the one that has to actually copy stuff into a string builder.
I didn't realize that was actually it's harder, or is the CPU more CPU bound, or?
This is interesting. I didn't realize you could do this.
Now you're getting fancy. Oh yeah, the fluent interface thing. So cool. In the years back, everyone wanted to do that.
Yes.
This is nice.
So you can see that rather than doing this, I've actually
the buffer.
I've saved a whole lot of operations by just doing this and calling the old version of that. It's not that much, but it's sort of nice to think about. Yeah, nice to do it that way.
Right on.
Okay. Let me think. So we've got these two strings in here, and then if we come up here, let's perhaps do it. Now we've fixed up the internal stuff without changing the API significantly. We got that, but that's not that much. So let's come up here and write the usage code first and try and do say this one as a string builder situation. And what I want to do just before we do that is maybe yeah, I want to have list string name Fred. I've already got Bob. So let's stick some player names in, and you can sort of see where I'm going with this. And so now we have sort of a more realistic way of handling these things. And I think what I want to do is still do it like this. So
Everything broke. Can't explain that.
and let's do so let's think about how we might do this, because even though
So silly. One of those days. Sorry.
that's all right. You can imagine, like, if we did something like the player hashtag plus player name as the identifier, you can imagine we could have like that. Maybe we will have like 2 Bobs, and so that's going to cause an issue with the fact that our identifiers have to be unique. So now we're getting back into sort of exploring what the API is like in actual usage. So for now, we might do for that names.length, sorry, .count. And we'll do it the same way. And then what the text might be is kick player so you can imagine we're implementing a network UI for this sort of thing, and we've got a bunch of players and we want to boot them off the system.
Right.
So I've actually kept this around, so I'm just going to copy this into Slack if you want to just grab it.
Oh, that's fine. But
just expanding out the so this is nice, is like it skips over the blank line just because we've done it in a nice way for selecting options, which is good. So now we have sort of this is the API that we want, more or less. And now we have to think about how can we get rid of this string append, this one, and this one. And I don't know, maybe we have let's just leave that for now. Let's say that's our interface. That seems quite nice. So any thoughts before we sort of as a starting point, any thoughts about what we might do with this?
Well, I mean, maybe we just use the its extensions for integers and then override item to give it a for the name, because it look like, I mean, right now, well, actually, yeah, no, we didn't, I guess we're back to where we were before, which is like the permutation of the 4 item methods. But the other thing too is we probably don't want to expose the working buffer to the usage code because that's ugly, right? But I'm not sure if that's avoidable.
Well,
or we could do the hashtag thing. I mean,
the hashtag thing is an option
at all.
That's not a ridiculous option. Thinking about it, well,
I mean, we could. I mean, no, it's probably gross, but
yeah.
there's the idea of providing sort of like an item list method. Like maybe we pass. We might end up having to do a delegate though, and that's off the table. I'm just thinking about.
Well, let's start thinking about our different methods. So let's make a list. So we've got hashtag. We've got and we're appending some number, for example. Now.
Right, I was thinking that could be automated though, like given like maybe the UI system auto appends the number when it sees the player multiple times, and then you don't have the +i anymore because it's done for you, kind of thing.
So that is an option. The only difficulty there is, and we may need to think about this, is the way our focus gets handled when an option goes away.
Right, because then the tag will automatically go away, and then you sort of like, yeah, you've changed the ID of what used to be there, and that will cause our problems we had before.
So I mean, that's not a ridiculous thing though. Like auto appending number is a thing. One idea I was thinking about is make +i API pass in the integer, seeing as like already we've seen this pattern has happened twice. It's like we're going to be doing this a lot. So it's not completely ridiculous to consider that we would just pass an index in. But there may be cases where we do actually pass a string. And you can imagine if this was unique, we may in fact want to pass in strings.
Right.
Escaping is a problem with this hashtag option as well.
You mean for the network, or?
So you can imagine some clever player like sticks their name as Bob hashtag ha 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 ha. Like, although right. I think if we just take it as like it's always the first pound symbol, we should be fine. So it's kind of ugly, but it's kind of nice because it's just like there is one string that we ever have to pass in, and we can actually get rid of this entirely. It's like plus hashtag I.
Yeah. Or even pass the integer into that one.
Yeah, I mean we could.
But I guess you don't really have.
We could do comma I.
I mean, you can make it auto.
So and let's actually keep the one we had that was. So these are our options. We've got that. We've got the player comma I maybe, or kick player comma I. So that's the thing we could do. Although this one doesn't really make any sense as such, because we've got sort of this uniqueifier and then that. Like this one makes a lot more sense than this sorry, this one here makes a lot more sense than this one. And this does have the nice property of it just reduces the amount of stuff that's getting passed around.
Right, but you're going to allocate the kick player. I guess that's up to the consumer to pass a string builder into that one.
So I think what we at some point we're going to have to pass a string builder around. So this then becomes UI dot buffer dot here dot append that dot append that. And I mean, I know you went at that, and sort of I kind of agree. However,
it makes me sad. That's all. It's no
we
longer
have to remember
like,
it's like this is not something we
clean,
can do though.
Clear.
Another thing we could do is we can't really do it, unfortunately, because it allocates. But you could think about, if we didn't care about allocation, we could do something like UI.item is, kick player 0 as like a format string.
Sure.
And maybe
like is it too much though? I mean, is it too much to do like, I don't know, maybe I'm probably overreaching, but what about like this?
That's not a bad idea. I think
like it's just, I know it's a little bit prescriptive or opinionated, but it's like, if this is the kind of thing we do all the time, like and maybe it's basically the same as your format string without as much flexibility, because I'm not giving you like this, right?
Right.
It's more like yeah, I don't know. It's just multiple items, all with kick player in front of it. So it's a prefix. It's pretty hard coded, but it's certainly like if that was the only thing we had to do, then I would certainly want to use that and avoid all the garbage and the wonky UI.
You can imagine the problem that might appear with that method of doing things, and that is you face the possible explosion of you've got item list, and then maybe you have checkbox list and so on.
Yeah, or we could make an extension method that okay, here we go. Yeah, I'm going off the rails into enterprise land. I was thinking like, we could now this becomes here's a horrible idea. Now it's an extension method on enumerables.
I'm just like, that's the same. It's the same piece of code, except you're missing a string here. But it's the same piece of code. You've just changed the order.
Oh, I thought what I was doing was avoiding the explosion of like no, I'm not doing that. Never mind. So, yeah, I wanted to avoid the number of the methods like checkbox and stuff, but then I'm not on all cylinders today, because that's just gonna mean that I have to write a bunch of extension methods.
So there's going down that road. There is one way of doing this that might be worth thinking about, and I'm not sure it's necessarily the best way, because I think it adds too much complexity. But StartList UI.start item. I guess UI.end item.
That's very ImGUI. Yeah, the more complex controls have that concept.
And you can imagine that then we could do things like this UI.kick play. Oh, sorry, UI.item. Kick player, and then we might have, say, mute player, and then maybe that's a checkbox, and then we can expand out from there. It's like, okay, we'll pass in the player name somehow. And that solves our problem of how are we going to deal with the fact that possibly if we have a list of things, we might want multiple items on it. We might want them to appear horizontally, for example. It's like, here's a player, kick, mute, promote, whatever. I think for now that the simplest thing to do is probably to do it like ImGUI. I think that might be the better way to do things. Looking at this, the nice thing about ImGUI is that it reduces, remember what I was sketching out before, it's like, okay, here's string text, and then we have, it removes this method here, so then we've just got two things. If we have StringBuilder, it suddenly we have that, and then that, and that. We have this situation occurring, and we've got suddenly 6 things to implement and deal with. Whereas if we do it like this, then suddenly life gets a whole lot more simple.
Well, we have 2 items,
yeah,
right?
It's like, yeah, we probably have that just to make
it
easy.
Round out the simpler cases, make the simple one simple. And
like we don't want to force someone to grab the buffer to do this.
Yeah, exactly. I liked our terseness before, but
well,
we'll do that. I mean, I think we'll end up with start item and end item anyway.
I think we may end up with that at some point, but we might not. Like, it depends how complex we end up going. So we'll keep going down this road, and the nice thing about that is then checkbox and slider. Like we had the thing before, where we're like now we can have random text in here and an identifier, because before we couldn't have an arbitrary chunk of text in there, if that makes sense. Like we couldn't do UI slider my value plus player names I.
Oh, right.
Or something. And now we can actually do that sort of thing as well. So that's a nice thing about that, because not only was the other problem, we have that explosion, like a 6-way explosion for item, but we then have a 6-way explosion for checkbox and slider and so on. And this way we can probably get away with just 2 of each.
Right. That seems not only cleaner but also more in line with like X and A and stuff too. So it's all. Yeah. I like it. Let's do it.
Like this seems nice and
symmetrical.
It's like, okay, we have 4 methods, but really we have 8 because we have to deal with this garbage collection issue, which is just unfortunate thing about C# that we just have to live with.
You mean like not being able to like what would that be? Multiple inheritance of a method or templating?
In a C++ situation, you'd have some mechanism by which you could allocate and format strings. It's basically, you'd have the same thing as StringBuilder, and so you may in fact have the same thing as this nonsense as well. It would just be on the stack or on some working buffer, some arena allocator, rather than having to do this StringBuilder. So at some point, no matter which system we do, and I think, as I was saying, like, you have an arena allocator, somewhere we have to provide to the end user some I don't want to say pool, but yeah, some working buffer that they can use.
Right.
So
that's reasonable.
And you'll notice something that I sort of have had in the back of my mind for a little while. this buffer is not the same as the internal working buffer we use here, because the internal working buffer, you can imagine the user is going to use this one. They might want to keep the contents of it. They might want to do all kinds of things with that. So if we're running around messing with it, you know, we're clearing it, for example. In fact, if we used it and we immediately clear it to stick this on the front of it, then we've got a serious problem. So
Right.
We need
But
a
that's still
buffer.
going to be non-retained state, though, right? The buffer. We don't want to replicate it.
So well, I'd actually do. Yeah. And I think what that's just going to become is just, we'll probably just be like not serialized, whatever the thing for that is, serialize or ignore, which is fine.
Well, is it, or aren't we going to clear it between frames? Just the way, like, we would.
In fact, I think,
you know, just the way we would do that.
I think what we're going to have to end up doing is, I think we'll have to think about this at a later stage. But yeah, you're right. Well, this will be network not serialized, whereas this one is serialized, and we'll have to figure out a way to make sure that everything. Like, you can imagine a case if this is serialized ignored, and the serializer is like, oh, I'd like a new UI update. It will write that as 0, and we can't have that. So. We'll have to think about that. And so in fact what we might do is make this wrap this in like a something or do like a custom serializer, because I mean this is sort of a special case. I think custom serializer is probably the way to go for this one, particularly if it's just, as I suspected, like just be focus and maybe a couple of other things. So I think we're quite happy with that design here. So let's think about, let's just leave that for now, and we'll come back to that. And now we have to make all kinds of new stuff.
Right.
So I'm just gonna come down to drawing, and I've got 3 new things to implement in drawing.
Righto. These kind of all end up being like, now we need an override for item, right? And then we just do the same stuff in other places.
So let's not start removing things too quickly. I think let's put item string back, just so we have something to work off, and then we'll get rid of it.
Oh, fair enough.
What do we call it? Name text, yeah.
Yep.
So let's flesh out this part of it, and then we'll come back into, because we're going to have to do update next. So let's finish off draw, because that's sort of where we were.
Here, it's fixing the world here. Okay. So yeah, so item 1 probably going to need to make an over. Wait, hold on. I thought we were going to try to avoid doing that.
So yeah, so let's finish out draw, and then we're gonna have to actually do something a bit clever. In fact, yeah, let's just go for now .to string and just call into that.
Oh, I see what you mean. Yeah.
Just for now.
That's it's just we're basically just getting it working.
Because at this point, we have to think about dealing with this hashtag thing.
Yep. Oh, you just, oh, whoops. Okay. I was just.
So basically what we've done, I think, is we've designed our API, and we'll get it working. We'll finish getting it working, and then now we actually have to implement the thing, and obviously that's going to be a little bit trickier.
Yeah. Well, I think we're at time if you want to
yeah,
do that next time. Or...
Well, let's make sure we're in a compiling state.
Okay. Well, I think I am. I just have to do the update ones too.
Yeah. So, I'm just gonna attack this out by calling that. That'd be real lazy. Checkbox, text to string. Checkbox.
Does the compiler help you with forwarding methods? I'm assuming it would, right? It's just a jump.
The JIT will actually do what's called what's it called? Tail call optimization.
Right.
And basically, this method, the way it works is all of the stuff, putting stuff onto the stack, is done by the caller. So when slider gets called over here, the caller will be like, all right, stick that on the stack, 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 jump into this code with a call that will also stick the return address onto the stack. It will jump, and let's say that was a string builder, it will jump to here and be like, it will hit this, right, and be like, oh, this is just a jump to here, and all of the stuff that we had for the arguments is still in the stack. And we'll run that and hit the return here and jump back to where it was before. So if all of the arguments are the same, and I think, I can't remember the details, like if I was optimizing stuff, I'd go and look up the details again, but I think if you like have no, I think it has to be the same set of arguments.
Yeah, right. In this case, we are calling, and we are doing a call.
Yeah, I think there's some case where you can have slightly different arguments, or you can add arguments or remove them or something. I can't remember. But basically, if there's the same arguments, this is just a jump because we'll just reuse this return.
Right.
And that can be useful in, like, this is just a trivial case, but there's like recursive functions become very fast in those cases because instead of the nice thing about this is it doesn't add a return value to the stack. Right. So you can imagine a recursive function doesn't grow the stack if you're like going like 10 levels deep, for example.
Right. You don't have to, and then you don't have to do the while true with an exit yourself, like, to avoid that.
Yeah,
you can just basically write it the way you want, and then it'll do the same thing.
It is equivalent to doing a while true situation with a return somewhere. Right. It's just the compiler will unwind it for you if you're lucky. So over here, let's just leave where I left it to do the hashtag thing. And then we'll stick that on this one because this is the one we want to get rid of. Get rid of me. And this check it builds, check it runs. and then we'll come back to it. So obviously this is the problem that we have, is we've got two players called Bob, and that's making life very sad.
Right. Yeah.
One thing I think we'd like to do, just before we finish, if you don't mind going a couple of minutes longer, and that is, let's actually finish implementing player removal, because that was the point of, like, that's why I wrote kick players. It's like, if someone selects that, let's kick that player. So I'm just going to leave that to you to implement, just for the sake of exercise. This is a sort of a simple thing.
Right. Yeah. Well, you say that. Just trying to think about whether it matters where I am in the collection. I certainly don't think I'm going to be able to remove them inline, right? I'll get one of those enumerables were changed while you were iterating it.
Well, we're not iterating. This is why I got rid of the for each that I wrote first and replaced it with this.
Right, but
so we haven't actually.
I'll just do it. I guess I was just wondering if every time I do something like this, it's like, don't I have to do the for loop backwards, or?
Well, we have to go forward, so this makes life a little bit interesting.
So I'll just say, well, we're using lists, so I'll just go player names, remove at.
Yeah, what am I coding here? There we go. So I'm just gonna.
Okay, both Bobs.
Yeah. So...
Goodbye, Bobs. See, yeah, I guess that's what we wanted. Yeah, once we kick the guy, the item is gone, so our behavior is to flip up to the top. Although, I almost, yeah, okay, that's fine. Although if you have a lot of like, that's sort of a usability thing. If you have a lot of players you need to kick, or a list of items you need to do a lot of things with, we might want to rethink that, because I would expect maybe that if I kicked Fred, that I would be on Rupert, not at start game.
Yes. So we probably should think about that. I've just had a couple of thoughts, and one is, let's solve that Bob problem, because we know how we're going to solve it in the real world. So I'm just going to quickly chuck that in. Append I, just so we're not constantly dealing with two Bobs. So that's sort of the garbage way of handling that. Now, of course,
I missed what you did, but that's fine.
So I've
just split it into.
I've got this.
Oh, okay. Typey. Thought maybe you were just gonna or just change the the name and not the text, but we're still using a single string method.
Yeah.
Okay.
So we'll do the hashtag thing later.
Yeah, next time.
Now there is one thing, and I'm actually surprised this didn't crash. And so what I'm just gonna do real quick is, if we are removing at I, we can do it this way. I++, get rid of this. So we can do it this way. Because if we remove at I and then do a ++,
oh, well, go out of bounds.
We'll go out of bounds. So you still need a blank statement there. The other thing you can do is I minus, and then have I++, because it's like jump back to the previous one. So both of these mechanisms work. I think I think I prefer
Like yours version. Yeah.
the
me too.
first one.
It's less writing.
Oh, you like this one? I actually don't
Oh.
know what's the better way to do it. I think I'm just thinking about it. I think this might be fewer branches. Now that I think about it, because the other one's like continue, and it branches back from 2 places.
I just like it because the for statement, the for loop is a normal for loop though, and you don't have to think about like, oh, where did the I plus go? It's easier to read this way.
Yeah, this is true. And if you want to be like sort of really ugly, you can do that. Not sure I really like that, but that's the thing you can do.
Yeah, there's a whole school of people who enjoy
But
that.
yeah, so there's multiple ways you can do it, but yeah, the trick is you have to make sure you don't go out of bounds. And I'm astonished actually that didn't crash. So, but that's fine. Yes.
Maybe because it's in the middle of the list, and we already have like it's not like it's in the middle of our sandwich of items, so the iteration is on up. Like we already have. There's always something to cover us there, right? Like if you put that at the end, it would have probably crashed, right? After exit, it might have crashed.
No, because the crash would happen on this axis because you've removed
right,
it and then. Yeah, but I don't know why it didn't crash, and I don't think we'll really worry about it too much at the moment. But you get the idea.
Yeah, my case of the Mondays is maybe it's rubbing off on you. Maybe I'll see you later.
That's all right. Okay, let's wind the stream down. Thank you for watching, everyone. So we'll come back next time, and we will actually do the hashtag thing.